Hello, Joseans! I am Sir Saul Apacible, your grade 8 mathematics teacher, extending a helping hand in understanding probability. This video discussion will focus on the key concepts of probability. Our objectives are to define probability, to illustrate an experiment, outcome, sample space, and event. Finally, count the number of occurrences of an outcome in an experiment using a table, tree diagram, systematic listing, and fundamental counting principle. Let's get started! People often deal with chances. Chances of winning in a lottery, chances of getting high grades in class, chances of raising company sales, or even chances of achieving one's dreams. This lesson focuses on chances, a concept known in mathematics as probability. Probability is a branch of mathematics that deals with measuring the likelihood that an event will happen. It is primarily concerned with making predictions about the occurrence of events. In the study of probability, certain terminologies need to be understood. These terminologies include the following. Experiment. It is a process that has a number of distinct possible outcomes in which the result cannot be predicted. Examples: tossing a coin, drawing a card, rolling a die, picking a number. All of these are experiments, and all of which has many possible results. Outcome. It is any possible result of an experiment. Examples: for an experiment of tossing a coin, the outcome could be a head or a tail. For an experiment of picking an integer, the outcome could be a number from negative infinity to positive infinity. Sample space. It is the set of all possible outcomes of an experiment. It is denoted by the capital letter S. Now, let us identify the outcome and sample space of this experiment. For an experiment rolling a die, the outcome would be a number from 1 to 6. The sample space is S is equal to 1, 2, 3, 4, 5, and 6. To write the sample space correctly, start with the capital letter S, followed by an equal sign, then an open-close parenthesis, and a comma in between the possible results. Remember to follow this way of writing your sample space. Event. It is a subset of the sample space. It consists of one or more outcomes of an experiment. It is denoted by the capital letter E. Example: for an experiment in drawing a card from a standard deck of 52 cards, some events include getting a black card, picking a red card, and choosing a face card. All of these are events in the experiment drawing a card. Now that we have discussed the key concepts of probability, we can transition to counting the outcomes of an experiment using systematic listing, tables, tree diagrams, and fundamental counting principle. Systematic listing. Systematic listing involves identifying the outcomes of an experiment, then listing and counting them. Examples on systematic listing. Determine the possible outcomes in the following experiment, and then write the sample space and the total number of outcomes. Experiment 1. Picking a color from the rainbow colors. The sample space is S is equal to red, orange, yellow, green, blue, indigo, violet. The total number of outcomes is 7, or we can write it as N of S is equal to 7. Experiment 2. Choosing a month. The sample space is S is equal to January, February, March, April, May, June, July, August, September, October, November, and December. The total number of outcomes is n of s is equal to 12. Experiment 3. Determine the possible outcomes in the event, choosing a single-digit odd number, and then write the sample space and the total number of outcomes. The sample space is E is equal to 1, 3, 5, 7, and 9. The total number of outcomes is n of E is equal to 5. Counting the outcomes of an experiment using tables. This is best understood with an example. List all possible outcomes for an experiment of tossing 2 coins, a 5 peso coin and a 10 peso coin. The possible outcomes for a 5 peso coin toss are a head or a tail. The possible outcomes for a 10 peso coin toss are a head or a tail. The list of all possible outcomes for the experiment is shown on the table. When a 5 peso coin is tossed, a possible outcome could be a head. When a 10 peso coin is tossed, a possible outcome could be a head. The rest of the possible outcomes follow as 5 peso coin head, 10 peso coin tail. 5 peso coin tail, 10 peso coin head. Finally, 5 peso coin tail and 10 peso coin tail. Hence, the sample space is the set head head, head tail, tail head, tail tail. We can also illustrate the possible outcomes using a tree diagram, another method in counting the possible outcomes of an experiment. Let's check out this figure. This is the tree diagram of the experiment, tossing 2 coins, a 5 peso coin and a 10 peso coin. We start by choosing either of the coins and make your first toss. The possible result for either coin is illustrated in the second branch of the tree diagram. The third branch illustrates the possible result for the second toss. This is the result connected to your previous toss. So if you had a previous result of head, it is still possible to get a second head or a tail. Listing all the outcomes, the sample space is S is equal to head head, head tail, tail head, tail tail. The number of outcomes is 4, similar to the outcomes presented using a table. We also have the fundamental counting principle. This is used to easily count the number of possible outcomes without the tedious process done by the 3 ways discussed earlier. The fundamental counting principle states that if one thing can occur in m ways, and a second thing can occur in n ways, and a third thing can occur in p ways, and so on, then the sequence of things can occur in m times n times p ways. Let's have an example to illustrate this. Here's the situation. Double O's Cafe serves 2 desserts, a cake and a pie. They also serve 3 beverages, coffee, tea, and juice. Suppose you will choose 1 dessert and 1 beverage. How many possible choices are there? If we use a tree diagram, the result would be like this. Choose a dessert, either a cake or a pie. This is illustrated in the first branch. Choose a beverage, either coffee, tea, or juice, like in the second branch. The third branch illustrates all possible outcomes in the experiment. Counting all of this will answer the question posed in the problem. How many possible choices are there? The answer is 6. Now, if we use fundamental counting principle, we have the number of desserts, which is 2, times the number of beverages, 3. Getting the total number of possible outcomes as 6. Much simpler. Application time. We have now discussed the key concepts of probability and the ways in illustrating the number of possible outcomes in an experiment. Let's apply these concepts in the following problems. Try to answer this in 5 seconds. Pause the video if more time is needed after the countdown. Number 1. Determine the possible outcomes in the event drawing a king from a standard deck of 52 cards, and then write the sample space and the total number of outcomes. The sample space is E is equal to King of Hearts, King of Spades, King of Diamonds, King of Clubs. The total number of outcomes is N of E is equal to 4. Very good if you got both answers. Number 2. An octahedral die is an 8-sided die. Determine the possible outcomes in the event getting an even number from rolling an octahedral die, and then write the sample space and the total number of outcomes. The sample space is E is equal to 2, 4, 6, and 8. The total number of outcomes is N of E is equal to 4. Good job in keeping up with this problem. Let's have more practice activity on the applications of the concepts we learned today. Identify what is asked in each problem. You are given 5 seconds in the video, and if more than 5 seconds is needed, please pause the video as I'll be sharing the answers right after 5 seconds. Number 1. Rene Alarcon is a disc jockey. He chooses different types of records for each hour of his 3-hour program. The possible choices are listed here. How many possible outcomes are there? First hour, R for rock, F for folk. Second hour, I for instrumental, J for jazz. Third hour, O for opera, C for classic. If your answer is 8, you are correct because 2 times 2 times 2 is 8. Number 2. How many possible outcomes will we get when a pair of dice is tossed? Dice is the plural of die. If your answer is 36, you are right because 6 times 6 is 36. For the next numbers, you are given 8 seconds to list the sample space of the following events. Number 3. A pair of dice is tossed. List the elements in the following events. Event A. The number shown in one of the dice is 5. If your answer contains the following, A is equal to 1, 5, 2, 5, 3, 5, 4, 5, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, and 6, 5, your answer is correct. Event B. The sum of the two numbers is 9. If your answer contains the following, B is equal to 3, 6, 4, 5, 5, 4, 6, 3, you have done well. Event C. A number less than 3 showing on each of the dice. If your answer contains the following, C is equal to 1, 1, 1, 2, 2, 1, 2, 2, good job! Did you get all the items right? If yes, splendid work! To summarize the key concepts of probability, we have experiment, outcome, sample space, and event. The different ways in counting the number of possible outcomes of an event is systematic listing, table, tree diagram, and fundamental counting principle. That ends our discussion on the key concepts of probability and on the different ways on illustrating in counting the number of possible outcomes in an event. Excellent work! Once again, I am Sir Saul Apacible, saying, with your mind, body, and soul, everything is possible.
So